Okay, today's lesson covers section 13.7 out of our textbook, and we are translating sine and cosine functions. So I'm hoping y'all think this is easy because we have done so much translating in all of our functions this year. So first off, remember that periodic functions, or no, periodic functions can be translated in the same way as other functions. Horizontal shifts are what we have referred to as inside the parentheses or inside the function of your function machine. Inside, and when you're talking about periodic functions, they are called phase shifts. Vertical shifts are outside the function or outside your parentheses, and they affect the midline and all the points. So, also remember horizontal shifts. If we're inside, remember we've talked about that has the opposite effect of what it looks like. Okay, that looks really weird. Opposite. Okay, and if it's outside, then we do the same thing, and you'll see that as we go along, and hopefully that's very familiar to you. Okay, so look at these pictures. We have two functions, and they're telling me g of x is a horizontal translation of f of x. So if it is a horizontal translation, what you need to realize is in that rule, as we just said, is this h going to be inside or outside your function? And if it's horizontal, it's inside, and so it looks like that, f of x minus h. Here we have a vertical translation, and that translation of k units would be outside our function or outside the parentheses. So that's what that's looking like. Now, if we take our parent functions of y equals the sine of x and y equals the cosine of x, and we put all the changes that we've talked about together, then our function is going to be y equals a times the sine of b x minus h plus k, or y equals a times the cosine of b times x minus h plus k. Now, the important thing that I want to mention here and remind you is this b, okay, is outside the parentheses, or it is multiplied the x, but the h, to see the true h value, you can't have a coefficient of x. So if there's a coefficient of x, you would have to factor it out. So just keep that in mind that when you see h and you're looking at a phase shift, you have to be on just x. So what's different from here to here? We have an A and we have a B and we have an H and we have a K, and each of those applies to these changes of our function. So first off, which one of those letters goes with the amplitude? And I know y'all know that that's A, but we need to remember that that's amplitude is always positive, so we put absolute values around that. Our period is 2 pi over b, because our period of our parent function is 2 pi, and b is going to change that period. Our phase shift, as we just talked about, is h, and our vertical shift is k. So here we have an example. What is the value of, excuse me, of h in each translation? Then describe each phase shift. Use a phrase such as 3 units to the left. So if I look at a, g of t equals f of t minus 5, then h is equal to 5. That 5 is inside, and we do the opposite of what it looks like. So that means that I'm going to take it 5 units to the right. Okay, so that answers A. And if we look at B, y equals sine of x plus 3, okay? H is not positive 3, because remember it's the opposite of what it looks like. So H is negative 3, in which case, and since H is negative, then I know I'm going to go 3 units. Okay, that doesn't spell units. 3 units to the left. And like I said, I think y'all are going to think those are the gimme questions because you know this so well from all the practice we've had. All right, so your next page, use the graph of y equals the sine of x for problem 2. What is the graph of each translation in the interval from 0 to 2 pi? Okay, so what I need you to know, before, when we have always graph problems, we wrote down our key points. Okay, and you could write down those 5 key points, but I find it a little bit easier to actually just graph it. And so I'm going to come over here and graph what I call my reference, my key points for the sine curve. And the sine curve starts at 0 and does this. And when I write down that it goes to 2 pi and it goes from 1 to -1, and of course that's pi units. And I know you can figure out that those halfway points are pi over 2 and 3 pi over 2. So here are my 5 key points. So whenever you graph the function, I should see those 5 key points every time. Okay, so on our particular graph, we have the sine of x minus 2. So that 2 is not inside the parentheses with there, so it is going to shift our graph down. It's outside, so it affects the y. Does the same thing, so we're going to go down 2 units. So I'm going to label 1, 2, -1, -2, -3. Okay. Um, and actually, you can go ahead. One of the things that's really important, and we didn't talk about it so much when we were just changing our amplitude and period, but now it's really important. And to remember that, why did that come up? Go away. That this is our midline, y equals 0. So when you're shifting, okay, then your midline is going to shift with any kind of vertical up and down movement. Okay, y equals 0, and it's an important thing to remember that midline because that I know you will remember that the amplitude goes up that amount and down that amount, and you'll see that it's going to make our graphing a lot easier. Okay, so I'm going to graph the midline. It should be a dotted line because um, it's not actually part of the graph. It's something that we're using to assist our graphing. So if I go down 2 units, that's going to take me here. So I wanted to make it light so that it didn't obstruct our graph, but it's just something that's going to help us graph. So the next thing we do, of course, is to figure out our period, and my period did not change. It's still 2 pi. So I go out, as we've done before, 4 tick marks, and I label that 2 pi, and I label the second one half of that, which is pi. Okay, so I'm ready to graph. And I'm going to, now that I've labeled both axes and graphed my midline, I'm going to go back and go find my key points. So my sine curve starts at the 0 or at my midline. So this basically are my new zeros because I've shifted it down. So it starts at a 0, ends at a 0, halfway between is a 0. You know, I want to do change that. Let's do this. This makes it easier to see. All right, starts at a 0, ends at a 0, halfway between is a 0, halfway between the first two is a max, and halfway between the last two is a min. So there are my 5 key points. They go between 0 and 2 pi that they asked, and since that's all they asked, we're actually just going to start there and do our best to make it look like the sine curve. There we go. Okay. I never object if you wanted to continue on and put arrows on it, but since the problem asked us just to do between 0 and 2 pi, we'll stop there. Okay, the next one, y equals the sine of x minus pi over 2. So this one is inside our function, and if it's inside, it's shifting it left or right, does the opposite of what it looks like. So this is going to go to the right pi over 2 units. Okay, I'm going to go ahead and label my graph the same thing. So I had 1, 2, -1, -2, -3. Okay, now my period again didn't change. Period is 2 pi. So if I go out and label this 2 pi and my second tick mark pi, that makes this tick mark half of pi, which is pi over 2, which is my phase shift. And you will see as we continue that it's always, I find it easier to always label the tick marks in terms of your phase shift because it can get really challenging to move these points left and right. A little bit harder than moving them up and down. Okay, so did my midline change? It did not change, so I still have y equals 0 as my midline. And now I'm going to start at 0. Except for before I start, I have to move right pi over 2 units. So that is right here. Oh, I'm going to change that color again, make it easier to tell the difference here. Okay, so there's pi over 2. That's my starting. 4 tick marks later is my period. And we can write that on there so help you remember. This is going to be 4 tick marks on my graph. And this is going to be 1 tick mark on my graph. Okay, so 1 to 4, halfway between is a 0, halfway between the first two is a max, and halfway between the last two is a min, which of course is just 1 and -1 in this case because my amplitude is 1. Now to go between 0 and 2 pi, this goes further, so I just have to continue the pattern. So hopefully y'all can see that this next tick mark should be down here. And then when I connect it, and it looks like that. So we got that one. Which translation is a phase shift? So which one is a phase shift going left or right? That, of course, is B. And which translation gives a new midline? As you saw, we did that in part A. So we're good to go. All right, look at the next one. Y equals the cosine of x. What is the graph of each translation? Oops, my bad. Okay. Use the interval from 0 to 2 pi. So we're doing the same interval that we just had. And the first thing that we want to do is draw that parent function. So my parent function for the cosine, y equals the cosine of x. This is my key points. The cosine doesn't start at 0. It actually starts up at 1, or a max, however you want to think about that. And it is doing this sort of thing. Okay, it's just a sketch, 2 pi. Halfway between is a min of at pi. And then halfway between the max and min are my zeros. This, of course, is 1 and -1. So, like I said, I think that's a little easier than writing our key points that we usually do. Okay, so I'm going to fix that because that really bothers me. And let's go on. Y equals cosine of x minus pi plus 5. So minus pi, this is inside. So it does the opposite of what it looks like. It's with the x. It's moving it right or left. Opposite of minus would be to the right. And why didn't I start that with the letter R? So this is moving to the right. And this is outside, so it's moving up. Okay? And when you're moving up, y'all, is what we talked about. That's affecting your midline, up and down. So we're going to have a new midline. Okay, if I'm moving it up 5 units, I'm going to have to label this one by 2's to get it on here. So I'm going to call this 2, 4, 6, -2. And I'm going to go ahead and graph that midline. My midline is 5 units up. So that, of course, is going to be between 4 and 6. So there's my midline. All right, and now before I graph again, I'm going to go figure out what this scale needs to be to simplify my line. All right, so my period is 2 pi, and that did not change. Okay, and if I go out 4 tick marks to 2 pi, and half of it is pi, okay, does that take care of my phase shift being a tick mark? It does. Okay, so that means that my period is, remember that's going to be 4. I'm going to write TM for tick marks. And right means I'm going to move it 2 tick marks when I actually graph it. So I've labeled everything. Let's go do our graph. Now, cosine starts at 1 unit above my midline. So my midline is here now. So my midline is, my new point is at 6. It would be at 6. Okay. But we have to shift it 2 tick marks to the right. So I start at 6, but I have to shift it right pi unit. So we've already done the up and down shifting. So once we get to this point, the only thing we have to think about is shifting it right or left to start off with. So I'm going to go right 2 points, which is going to take 2 tick marks, which is going to take me there. Then I'm going to go to the end of my period, which we said was 4 tick marks. So 1, 2, 3, 4. Okay. And then I'm going to go to my reference, and that means halfway between these two is a min, and if a max is up 1, a min is down 1, and then halfway between those points are my zeros. Okay, and again, I have to go between 0 and 2 pi, so I've got to figure out this pattern, which hopefully y'all can see means this is right here at a 0, and this is at a minimum. And I will connect those between 0 and 2 pi. Something like that. And there's my cosine graph. Okay, all right, let's look at the next one. Y equals cosine of x plus pi over 3 plus 3. So I have plus pi over 3 means I'm going to move to the left. and plus 3 again moves up. So I'm going to go graph that midline again. Uh, let's go with that color this time. Oh, I didn't label. My bad. All right, so let's go. I think we should go in twos again. So let's go 2, 4, 6, -2. All right, now go back to my midline. And between up 3 units, so I'm going to be between 2 and 4. So that's my new midline. All right, and before I actually graph, I need to go figure out my x scale. So we've talked about this. It's moving pi over 3 units to the left, and that means that's my phase shift, and that's what I'm going to label my tick marks. So my first tick mark is going to be pi over 3. So we're counting, in essence, every denominator is 3. 1 pi over 3, 2 pi over 3, 3 pi over 3, which is, of course, pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, which is 2 pi. And since we have to go to the left, I'll go ahead and label that one negative pi over 3. So I've got my scales, I've got my midline, I'm ready to graph. Where does my cosine curve start? It starts at up 1 from my midline, so I go to my midline and go up 1. Now, do I get to stay there? No, I have to shift it left 1 tick mark. So I'm going to write that left meant I went 1 tick mark. Okay. My period in this case, my period is still 2 pi. It didn't change. How many tick marks is that in this graph? That's actually 6 tick marks. Okay, so that does change according to my scale. Okay, all right, so I went up 1 and then to the left. That's my starting point. And then I'm going to go 6. 1, 2, 3, 4, 5, 6. Or if you prefer, know that your period ends at 2 pi and we went to the left 1 tick mark. Okay, halfway between or at pi and over 1 tick mark is my minimum, which is 1 unit below my 0. And now I'm going to go halfway between these 2 points to get my 0, which is going to be on my midline. Halfway between those two, on my midline. Now, do I cover everything? I got to go here again to cover 2 pi. So this is 1.5 away, so 1.5 away is going to actually put me right there. So to graph, I don't know where, it's not easy to start right here at 0, so I'm actually going to start a little bit past it. If you want to start past it, I don't like that one, sorry. Let's see if we can do this better. Not really. Oh, goodness. All right, last time, and then I will move on. Some of them are easier than others. There we go. All right. So that was our translating our cosine graph. Now, the next two problems, you're going to be so excited. We get to put all 4 changes on the same graph. Okay? So it can be a little bit challenging, but if we do the same kind of steps that we've been doing, it's going to be fine. So let's look at, first off, y equals -3 times the sine of x minus pi over 3 minus 3/2. So the first thing I always want to do when I have multiple changes like that, I'm looking to see what the parent function is. So my parent function, of course, is sine. So I'm going to come over here and draw my reference graph. And the other thing is when you do this, y'all, it just helps it get in your brain. Okay, every time you draw it, it's solidifying it. So boom, sine curve does this, starts at 0, goes up, period is 2 pi, halfway is pi, then I go up to 1 and down to 1. Now, watch how you can help simplify this. On my reference graph, this is my max. Well, you got the idea. That's the max and that's the min, which in this case now, here's my a value of 3. So instead of marking this at 1, excuse me, I know it's going to be 3 and -3. And then when I have a negative, I like to go on my reference graph and put it in because sometimes when you have so many changes to a graph, it's hard to remember every little thing that you got to do. So that takes care of those two things. What does this 2 do? Hold on one second, y'all. Got a bug in my throat. It's spring here, so the pollen is coming out to get me. Anyway, so the 2 is affecting my period, 2 pi over 2, and that, of course, is pi. And then the minus pi over 3 means I'm going to shift it to the right. And the minus 3 halves means I'm going to shift it down. And so what we've been doing our y-axis first because it's usually easier. So let's go do that. And I'm going to label this by, go ahead and do it by 1. So that's 1, -1, -2, -3, -4. And I'm going to go ahead and graph that midline. So this is, because it's simple, it was at 0, and because my graph went down, it is now at -3 halves, which is 1.5. So here's my midline. And I got that part covered. So now I got to figure out labeling my x-axis. Okay, so my x-axis, here's my phase shift, is pi over 3. So I'm going to do the same thing we just did, and I'm going to label that tick mark pi over 3. I label it up here. Pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, and 6 pi over 3, which is 2 pi. Okay? So are we ready to graph? So I'm going to graph, and I'm actually going to go up here and say, okay, my period is pi, which is how many tick marks? That's 4 tick marks. And I went right pi over 3, which on my graph is going to be 1 tick mark. So when I do my little shifting and putting these key points on my graph, then that's going to help me keep things straight. So here's my 0, but with the sine curve, we do start at 0. And so I'm going to start on my midline, but I have to move that point 1 tick mark to the right. And then I got to find the end of the period, which we already figured out was 4 tick marks. So 1, 2, 3, 4. That's the end of my period. So I went from here to here on my reference graph. Now where's my middle point, halfway between? Okay, and now I would normally go to a max, but remember we knew it flipped, so I got my negative. So I'm going to go halfway between these 2 points. And that, of course, oh, y'all, I'm so sorry. It's not 4 tick marks. It's 3 tick marks. Are you yelling at me yet? I hope you didn't turn it off. Keep listening. 3 tick marks. 1, 2, 3. So 1, 2, 3. This is the end of the period. Okay? And so halfway would be halfway between that box. Okay. So halfway between these two is going to be my min, and I'm going to go down 3. So this is like 1.5. And I hope you know half of 1.5 is half of $1.50 or 75 cents. So that's like 3/4 of the way. So I'm going to be here, and I got to go down 3. So that's 1, 2, 3. So I'm halfway between the box vertically, but 3/4 of the way that way. Okay? And then between the other two, again, I'm going to go 3/4, which is right here, and then up 3. 1, 2, 3. So that puts me right here. Okay, I'm not anywhere close to between 0 and 2 pi, so I'm going to take this and I'm going to do it again. I start at 0, I end 3 tick marks later, which is right here. Halfway between is a 0, and then halfway between those first two, I have my min, and then halfway between my last two is my max. But I hope you can see, y'all, that starting and stopping point, knowing that, okay, when you put these key points, go to the beginning and go to the end, and then the rest of them come pretty easily. So hopefully you can see the pattern. This one should be up about right here. Nope, I did that too close. My bad. It should be right here. And then this one is 1.5. These are 1.5 apart, so 1.5 is like right there if you want to start it there. Okay, so let's do our best to connect those. And actually, I'm going to pause and bring it back to you so you don't have to watch me do all mess up. Okay, be glad you didn't have to watch me graph that because that wasn't fun. But one of the things I do want to point out here, y'all, again, it says from 0 to 2 pi, okay, which means you could have stopped your dot right there, and I'm okay with that. If you decided to continue, just know, remember that these are all maximum values. So when you draw your line through, don't make that arrow go through. Okay, I'll have to take off for that because it's really important to understand where the max and min values are of these graphs. Okay, last graph, y equals 2 times the cosine of pi over 2 times x plus 3 minus, I mean x plus 1 minus 3. So again, I always start off with that reference. Before I go anywhere, I'm going to write down those key points. Cosine starts up here at a max and ends at a max after a period of 2 pi. Halfway between is a min at pi. All right, so I'm going to look over here. Before I label that 1 and negative 1, I'm going to look over here and go, oh, it's really 2 and negative 2. Okay, my pi over 2 is affecting my period. So my period is 2 pi over pi over 2, which is keep, change to division to multiplication, and then flip. My pi's cancel out, leaving me with a period of 4. Okay, my phase shift is 1 unit to the left, and my midline has now, I don't know why I put that, because it's clearly not up. It is down 3. Okay, so um, let's go ahead and hold on 1 second. Okay, I just want to make sure we got my scale right because I know you don't want to see a mistake. Okay, all right, so I'm going to move it down 3, and I wanted to make sure it would fit if I went ahead and kept it at ones, because I'd really like for you to see it right next to the other one, um, what kind of change. So I happen to know, knew there was something I forgot. Okay, so there is my scale. I'm going to go down 3. So remember, we always, after I label that Y scale, I'm looking at my midline to see if it's going to move. So I'm going to go graph that at down 3. So that's right here. Y equals negative 3 is my new. Okay, well, that was terrible. Let's try that one more time. Y equals negative 3. Okay, and let's go talk about our x-axis. My period is 4, and I'm shifting it left 1. So I'm going to go ahead and I can make each tick mark. My fourth tick mark will be 4, and I'm labeling them by 1s, as you can see. So that makes things pretty easy as far as our shifting goes. So when I graph this, 4 is going to be, my period is going to be 4 tick marks. I made sure this time. My phase shift of left is going to be 1 tick mark. Okay, so I'm starting off, and here is my midline. And where does it start? Well, my midline, I would actually go up 2. So up 2 would be here, but I have to go left 1 tick mark. So that's my starting point. So once I have my starting point, then I'm going to go see how many tick marks for my period. 1, 2, 3, 4. And then halfway between those is a min. Now my min, remember I went up 2 from my midline because of my parent function there that I'm looking at. I went up 2 to get a max, so I'm going to go down 2 to get a min. That's why I was making sure that would fit on our graph. Okay, down 2 to get to our min, and halfway between those points are my zeros. So I have a 0 here and a 0 here. Oh, we have to go between 0 and 2 pi, which means I need to extend this. And I have a 6, but I hope y'all can work with me and realize that 6.28 means you got to go a little bit past that. But I know that y'all can continue. So, max, 0, min, 0, max, 0 at the next tick mark, min at the next one, and 0 at the next one. Of course, we would be at a max. Okay? So, um, just so you don't have to, anyway, I'm going to pause. I'll come right back with the graph complete. So that's what it's looking like, and I graphed between 0 and 2 pi because you can't really see it goes to 6.28, but it would. And that is our complete graph, and I kind of wanted to do it on the same scale so you could see that that 3 clearly is a vertical stretch that is longer than our vertical stretch of 2. All right, last 2 questions. You will have them on your test, and I hope you'll realize that they are gimme questions. All right, so looking at it, what is the equation that models each translation? Okay, this first one, if I'm going up, that's my k value, which is outside my parentheses. So this is y equals cosine of x plus pi over 2, because if it's up, I do the same thing, which means I'm going to add. And then I go to this last one, pi over 4 units to the right, that's my h, and that means it's going to be inside, and I do the opposite of what it looks like. So if it's going to the right, When normally you would add, we're actually going to subtract. So it becomes 2 times the sine of quantity x minus pi over 4. So that finishes our translation of sine and cosine functions. If you have any questions, I hope you will come see me or email me. Thank you very much.